All right, welcome back, everybody. Today's lecture is actually going to be a very, very short one. We're doing section 7.5, which is all about strategy for integration. But the good news is you've already learned all the integration techniques that we're going to learn in this course. So we had integration by parts, we had trigonometric integrals, we had trigonometric substitution, and we had partial fraction decomposition. Now we're just going to briefly talk about some strategies, but there's really not that much to cover, as you're going to see. So let me get the slides and we'll get started. Okay. So first thing is I have to say a couple things here. Evaluating integrals is an art. So it's an art form. It's a tricky thing to do and it takes a lot of practice. So if you feel like you struggle a lot with evaluating integrals, just know that that is normal. There's nothing wrong with you. It's a difficult thing to learn how to do and it just takes a lot of practice. So don't feel bad. Don't feel bad. And you will get a lot better the more that you do it. This is also one of the reasons that students tend to find this section of Calc 2 kind of uncomfortable because it's not like differentiation where there are just rules that you can apply. It's like, oh, power rule, product rule, quotient rule, chain rule, and you just like go through it. There isn't anything like that in this with integration, right? There are some suggestions and there are some guidelines, but there's no hard and fast rules that say this is how you do it every single time, right? You have to basically feel your way around an integral and massage the kinks out of the integral until the integrand is something that you know how to work with. The other thing is we've actually only scratched the surface of what integration techniques exist. So this is not the end all be all of integration techniques. There are hundreds and thousands of them, and you can learn more of them if you want to as you go further in your math education. But this is about all we're going to learn. Integrals range from easy to impossible to evaluate. Easy to impossible to evaluate. So there's no way to really show the entire gamut, but I'm going to show you some trickier integrals in just a moment here. The other thing I'll say is that oftentimes math research involves evaluating an extremely tricky integral. So for me, a lot of my research boils down to trying to evaluate difficult integrals in multiple dimensions, because a lot of my research involves n dimensions, where n is any positive integer. So I get a lot of multiple integration problems, and I get a lot of tricky integrals and I have to try to figure out just even how to evaluate them if they are even evaluable. That's not even guaranteed. So just so you know, this is actually a lot of what math research can be like depending on what field of math you're doing your research in. But just know that with time and experience, you will get better at integration. So my best suggestion, even for like the exam, is to do the homework, practice the homework. There are other examples in the book as well. So if you want to do more integrals, you can do the ones that are in the book and they will give you a lot of good practice. Remember, you also have resources like Wolfram Alpha at your disposal, and Wolfram Alpha can evaluate these integrals. It can compute them for you. So if you want extra practice than just the homework, go to the book, grab an example or another problem from like section 7.5, try to evaluate it on your own, and then plug that integral into Wolfram Alpha and have it give you the answer and see if you're right. And if you're not right, try again. Okay, so on that note, one thing I wanted to mention is this. So the MIT Integration Bee. So each year, the Massachusetts Institute of Technology, MIT, they host an Integration Bee where contestants compete by evaluating extremely difficult integrals. So it's kind of like a spelling bee, but in this bee, contestants are given really difficult integrals and they have to try to evaluate them as quickly as they can. And the integrals can be really, really difficult and really, really tricky to do. So if you really enjoy integration, you might really be into the integration bee. You can look up videos of it on YouTube. I have a link here for the qualifying exam for this year's integration bee, which is already passed. I think they hold it in January, but I can't remember. So if you follow this link, that will just send you to the exam that you have to be able to pass just to compete in the integration bee. And I pulled a couple of the example integrals from this exam here. So I think there's like 20 or 25 on that exam. But look at this integral, like x to the 1 over log x, log being the natural log in this case. Or how about this one? This one you're integrating over the binomial coefficients, right? Binomial coefficients. So this is x choose 5. And then this one I actually thought was pretty cute. This one I found out that I was actually able to evaluate it on my own in about a minute or so, just by thinking about the picture. So I'll explain how to do this one. Um, this one is basically the absolute value graph shifted down by 1, and then you take the absolute value of that again. So if you remember what the absolute value graph looks like, it's the V, right? But then if you shift it down by 1, it looks like that. But then if you take the absolute value of that, what you get is you get a little peak there. So it kind of looks like a W. So this is the graph of absolute value of x minus 1 in absolute value. That's that graph. And the area of this is just 1. So it's just 1. And the bounds here, this is negative 1 to 1. And so I was thinking of the picture when I looked at this integral, because at first I looked at it and I was like, whoa, that's insane. Like, how could you even figure that out? And then I realized that there's a cute trick to it. It's basically just the absolute value graph, but shifted down and then you flip it up. So then if I were to do this again, if I were to basically take this, shift down, and then do absolute value, now I'm going to end up with 2 peaks. So you'll end up with 2 peaks that look like that, and so. And each one of these will have area 1, each one of those peaks. So that's why they have this symmetric interval from negative 2023 to 2023. Also, they're being cute because it's for the year 2023. Kind of cute, right? So this one, if there's 2023, the answer to this integral is actually going to be 2023. Because for each one of these shifts and absolute value taken, you're going to get another one of these peaks. So if it's 1, you get 1 peak. If it's 2, you get 2 peaks. If it's 3, you get 3 peaks, and so on. So if it's 2023, you get 2023 peaks. There you go. Anyway, so for those of you that are really into integration, you should check out the integration bee, check out the videos, and see how those contestants go through and solve them all. It's pretty amazing to watch. Okay, so what is the strategy? There's not a ton of strategy to evaluating integrals, but there are some basic guidelines. So first of all, and I'll say this in activity as well, simplify the integrand if it's possible to do so. Maybe pull out constant multiples. So if you see that you can pull some number out, you should pull that number out. Rewrite expressions or integrands using identities. So with the trigonometric integrals, we were able to evaluate those by using a lot of trigonometric identities, right? So maybe try that. If you've got a rational function, perform the division algorithm. If you notice the degree of the numerator is greater than the degree of the denominator, perform the division algorithm, and that can help you out. It can give you a simpler integral. Separate expressions into multiple fractions. So this is a technique that I pointed out in the last lecture when we had this integral. If you remember it, it was integral x plus 1 over x squared plus 1. This one, it seems like it's going to throw you off, and you try to do a u substitution and it's not working. The thing to recognize is that you can rewrite this fraction as 2 simpler fractions because you have a sum in the numerator. So this is the same thing as the integral x squared plus 1 under x plus integral x squared plus 1 under 1. And then each one of these individual terms would be easier to integrate on their own. This one you can use a u substitution. This one you can use arctangent. So that's what I mean by consider separating expressions into multiple fractions. That can simplify things. Perform partial fraction decomposition. If you've got a rational function where the degree of the numerator is already less than the degree of the denominator, factor the denominator and use partial fraction decomposition. That's one thing you can do. And then lastly, just in general, I know I say this a lot, but just massage, right? Try to tweak your integrands until you've got all the kinks out and it's basically as smooth as you can get it. And then maybe then you'll be able to evaluate the integral. So a lot of it is algebraic massage. Okay, other than that, your choices are pretty limited. Look for an obvious substitution, inverse or otherwise, maybe trigonometric substitution, maybe u substitution. Just look for a substitution that could help. Even integration by parts is a substitution technique. The other thing is try to classify the integral according to its form. So if it looks like it's an integration by parts, try integration by parts. If it's got trig functions, maybe you can use those trigonometric identities to tweak things just right. If you've got radicals, maybe a trigonometric substitution will help. If you've got a rational function, maybe partial fraction decomposition will help. So there are some guides based on the form. But again, just because you think it might be IBP does not mean that it's going to be IBP necessarily. Or just because you have trig functions doesn't mean you're going to need to use identities, for example. There's no hard and fast rules. And then the last bit is just this: try again. Try again. It's an art, it's a skill. It takes a lot of experience and practice to get good at it. So just keep trying. Don't give up. You can do it. Just keep at it. All right. Okay, and that's it. So on that note, let's play. The activity that we're going to do is literally just practicing a bunch of integrals. I will give you 5 integrals that I picked, and you have to figure out what technique you're going to use, how you would evaluate them, and that's it, just to get some practice and to have some fun playing with them. All right. On that note, I'll say goodbye. I'll see you next time, and thanks again for listening.